In our case study video for algorithms, we looked at an algorithm called linear search, where we wanted to find if a particular element exists in a list or not. In this video, I wanted to find the problem of searching, and we're going to use linear search to do that as well. So the searching problem is determining if a particular item is in a given collection of items. All right, so that's pretty straightforward, and we can see that. But the question we might ask is, why do we care about this problem? Well, it's a very common task. It's a task that we're going to perform a lot with other algorithms and in the computer, but it's a task that we do in our everyday lives that we've been doing for years. Searching data sets can be very costly, and so if we don't search efficiently, we could be wasting a lot of time. And because it's something that we commonly see and it's something that we commonly do in our everyday lives, it's a really good platform for talking about the complexity of algorithms and how do we measure efficiency. And so that's why I'm starting with searching problems for this lecture series. Before we go any further, let's revisit linear search. I'm going to quickly go through this since in a previous video we already covered it. But the problem is, given a list of numbers, determine if a particular number exists in the list. So the input that we're going to use is L, which is an unsorted list of n numbers. K is the target number. So we're trying to ask, does K exist in L? And if K is found in L, we're going to return true. If it's not found in L, we're going to return false. Okay? So the way we're going to do this is we're going to start at the beginning of the list, and we're going to iterate through the entire list, checking to see if the value that we're currently at is K. If it ever is, we'll return true. If we get to the end of the list and we have not returned true, we will then return false. So again, searching is going to be the problem that we're going to use when discussing complexity. So you're going to learn different techniques, different methods for evaluating how efficient or inefficient a particular algorithm is. And the examples that we're going to be using will be searching examples because it's something that's easy to grasp at the beginning. We will use linear search. That's why I kind of reiterated it in this video. But we're also going to use other searching algorithms, and one that we're going to see in the next video is binary search. And so as we go through learning these tools, we're going to keep revisiting these searching algorithms. I'm going to introduce a few more, and we're going to use that as kind of our platform for understanding complexity analysis. And then once we do that, we'll be able to start applying complexity analysis to other algorithms as well.